Hello everyone, welcome to Study IAS exam, and today I'll be talking about one of the most important topic regarding the energy sources. So we all know various type of energy sources. So today we'll be discussing about some of the alternate energy sources, right? So what is the overview about it? We know that coal, oil and natural gas provides over 85% of the total primary energy used around the world. Nuclear reactors, hydropower, they together produce less than 10% of the total world energy. Wind power, solar system, geothermal energy, and other alternative sources make up the final small fraction. So conservative estimates place their share to the 3 to 4%, but some experts believe that it could be high as 10 to 15% we consider. So fossil fuel like coal, oil and natural gas produce 85% of the energy. Nuclear and hydro produce less than 10%, and other alternate sources, energy sources, produce 3 to 4%, and some experts say that it produce around 10 to 15%. Okay. So what are the alternate energy sources which we are talking about? The sources, one is wind power. Wind power utilizes kinetic energy in the earth atmosphere, and it is said that it is equivalent to 10,000 trillion kilowatt hour of energy if harnessed properly. Solar energy is the another alternative source of energy which is being used widely throughout the world. Photovoltaic cell which are 14% efficient, they cost around $4 per watt, but now the rates are falling. Then we have a geothermal energy which is used in 20 countries, can cause air pollution and release various type of salt and toxic metal. Then we have a ocean energy, like if we need tidal energy and we need tides, so we need around greater than 15 feet or 3 meters difference. So OTEC use temperature difference. Okay, then biomass and others, we have a biomass, ethanol, methane, hydrogen, MHD, waste to energy are also promising alternate sources. Then we have various energy conservation techniques are there. So best way to meet future energy demand is we need to produce energy from the various sources. Now we are discussing about wind power. So one of the earliest form of energy used by the humankind. So wind is caused by uneven heating of the earth's surface. Its energy is equal to about 4% of the total solar energy. The potential is 10,000 trillion kilowatt hour. So ideal locations are area where constant fast wind and no obstacles. An efficient windmill can produce 175 watt per meter square of propeller blade area at a height of 75 feet. Cost of generation 1 kilowatt of energy is 8 cent by wind and 5 cent by hydro and 15 cent by nuclear. And California is the largest utility purchaser of the wind power. Denmark lead in the world and aims to get 10% of energy from the windmill. Now we are coming to the solar energy, which we are utilizing the blue plates throughout the world. So a direct use as heat. Greenhouse and solarium use glass windows to tap the heat. Flat plate collectors on rooftop can provide 1/3 of the space heating by energy. There are passive system where you can do windows, you can put your solar plates in the windows, they will be acting as a collector only. Then there is an active system, we can utilize fan, pumps, machinery to move the heat, right? Then we have a solar electricity with the help of photovoltaic cells. So photovoltaic cells are made from semiconductors, example silicon, germanium. Efficiency is 14%. The cost of producing electricity is $4 watts per watt. Okay, so we have a thin film technology which reduces the cost, used in lighthouse, boat, solar village, remote areas. Large solar system use trackers, use minor reflector for maximum efficiencies. Then we are coming into the geothermal energy. Natural heat from the earth interior, use directly heating or indirectly electricity. There are various type of steam which we utilize: dry steam, wet steam, then source stream, then sweet streams is there. So electricity generation method are flashed steam method, where high temperature geothermal brine heat is injected water, then that water is converted into steam, then steam runs the turbine and then it produces electricity. Other than we have a binary cycle where we utilizes low boiling fluid, example isobutane, ammonia. They all work in a closed system and are not hot enough to steam. Some of the facts are used in 20 countries like USA, Mexico, Italy, Iceland, Japan, former USSR, etc. But there are a lot of environmental impacts are there like air pollution, release of dissolved salt, toxic metals, mercury and arsenic. Right now we have a ocean energy. Ocean energy means tidal energy or ocean thermal energy conversion. So under the tidal energy we are having a based on difference between high tide and low tide. So we need around 15 feet or 3-meter difference in the water height in order to generate power from the tidal power. So normally the Bay of Fundy is known for high tide waves. So there are a lot of tidal substation are being drawn over there. Some sites are there in China. And under the ocean thermal energy conversion OTEC, they use temperature difference between warm surface water and cold surface water. They utilizes low boiling fluid like ammonia. The vapors drive turbines. Cold water condenses and vapor are back to liquid. Again, they are being heated up. So power can be used on a floating plant or shipyard or in a shore. Then we have a biomass and other alternate sources. Biomass and biofuels energy we are producing from biomass like wood, crop, organic waste, ethanol from sugarcane and corn, methane from anaerobic breakdown in the landfill, wastewater and plant. Waste to energy means burning garbage can produce heat and electricity, require high pollution control. Like example is there in the Hamburg, Germany use municipal waste to generate electricity. There are another energy sources like magnetohydronomics MHD. They ionize the gas and pass through the magnetic field which generate electric current. They are 20 to 30% efficient. Then we are utilizing hydrogen, that is clean burning form and used in the fuel cell. Then methanol power in Indianapolis and the race car. Now, what is energy conservation? Why it is important? So, first of all, why we are talking about the energy conservation? Because it helps in improving energy efficiency, which is the best way to meet energy demand without adding to air and water pollution. So, USA has survived the 1970 energy crisis by curtailing waste and improving the efficiency. Now we can generate, how we can generate and improve efficiency? Like if we are utilizing properly, then we can improve the electric motor efficiency by 200%, light bulb by 300%, refrigerator air conditioner by 400%, and gasoline mileage of automobile by 500%. Okay, so if we see there is a company called Volvo which is producing a car which is called LCP 2000, which has met the US safety standard of 0 to 50 miles per hour in 11 seconds. Now if we go by like what are the key takeaway? So alternate energy sources are various, diverse, abundant and continuously improving. While some have environmental impacts, they are essential for a sustainable future. Energy conservation is the most cost effective and immediate solution. Investment in new technology, infrastructure and innovation is crucial. So there is a clearly good hope for energy abundance and cleaner future.